Hi, good morning. And today we are going to explain the topic of sinusoidal functions. My partners are Fabio, Carlos, Ricardo, and Service, and me. The basic trigonometric functions are sine, cosine, and tangent. And what are they? It's a function that is like a sum function in the sense that the function can be shuffle, straight, and comparison. And the characteristics is absolute, in this case is 1 and 1, period, and pi over 2, and phase shift, and the vertical shift.
Hi, my name is Jose Fabio, and in this case I'm going to explain the sine and minus sine function. Well, first we start with the sine function. In the graphic part, it starts from the center, then it goes over to the maximum point and goes down to the minimum point to finally end in the middle point as the beginning. The general form from the sine function is a sine bx plus minus c for plus minus d. Well, in order to get the general form from the graph, we start from the amplitude. The amplitude is the maximum minus the minimum point between two. So in this case is 1 minus minus 1 is equal to 2. So 2 over 2 is 1. So the amplitude is 1. The amplitude means the distance between the center to the maximum and minimum point. Then we get b. b is 2 pi, which means 180 over period. The period is the initial point, which in this case is 0, minus, well, plus the final point, which in this case is 2 pi. So 1 plus 2 pi is, no, 0 plus 2 pi is 2 pi. So this is the period. So 2 pi over 2 pi is equal to 1. So in this case, b is going to be 1x. Now I clear the value of c. The value of c is equal to minus c is equal to x over b. b already got it, which was 1. And minus, well, x minus over 1, it is 2 pi, no, pi over 2. And due to the fact that we have a minus, we convert this and it gets minus pi over 2. Yep. And finally, v is similar to the amplitude, but in this case we're going to sum the maximum plus the minimum point and divide it over 2. That's all.
So I'm going to explain the cosine function. Well, first of all, to see if it's a cosine function, you gotta see if this, the starting point starts at the highest part, and then in the middle, at pi in this case, it goes down to the lowest point. So the period is exactly the same as the sine. It starts in 0, then 2 pi, then 3 pi, and then it ends at 2 pi in the highest point. And to get the general function of the cosine is exactly the same as sine, but instead of putting sine here, you put cosine here, and you use the exact same formulas as this one.
Hi, I'm Carlos and I'm going to talk about the tangent function. As we saw, the cosine and sine are very different to this graph we have right here. In here we have that the graph will just cut in some specific places along the graph. And it will have just a period of minus p over 2 to p over 2. So it will have a period of p. and this is the positive function. Then here we have the negative function, in which we can see how it moves differently from that one. And we have the same period from minus p over 2 to p over 2. And in here the transformations are very similar to sine and cosine. We can move it in vertical, horizontal, and we can change its period. And finally, the applications in real life for all the sine, cosine, and tangent functions. We have very specific examples. For example, a bridge. A bridge can consist of a sine, cosine, or tangent function. Here we have the two posts of the bridge. We can detect a cosine function because it is cut at the half of the graph. It can also be a roller coaster, a road, or a frequency wave, as it can be seen here. And also in a park, we can use it to measure the period or the time that a wheel will do a flip. And well, so to sum all of this, we can say that applications in real life for these functions are all in the engineering aspect, like bridges, roller coasters, roads, and frequency waves, for example, this one. And that's all. Thank you so much for your attention. And this was sinusoidal functions.